Hi, boys and girls. This is the video in which I do the problems for 7-1 practice problems in your new workbook on page 391. All right, on page 391, it says for exercises 1 through 4, use the figure at the right. In the figure, line M is parallel to line N. For each pair of angles, classify the relationship as alternate interior, alternate exterior, or corresponding. All right, so angle 2 and angle 7. Let me fire up a pen here. Angle 2 and 7. So 2 is right here, and 7, oh, I don't want to do anything weird like that. No, no, no. Don't do weird stuff. 2 and 7. So these are our two angles here. These are on opposite sides of the transversal, so they're alternate, and they're in between the parallel lines, so they're alternate interior. Alternate interior. Okay. Next up would be 1 and 3. So we're looking at 1 right here and 3 right here. Okay, these are corresponding angles. If you were to look at this group of 4, you would say 1 is the top left. This group of 4, 3 is the top left. Because they're both top lefts, that makes them corresponding angles. Okay. 4 and 5. This would be 4 and this would be 5. They're on opposite sides of the transversal and they're outside of the parallel lines, so they're alternate exterior. Sorry about the handwriting. Maybe if I turn this tab a little bit, it'll get better. Okay, and lastly we have, let me clean this up a little bit because I'm making a mess over here. Lastly, we have 5 and 7. So this is 5 and this is 7. All right, 5 is the bottom left, 7 is the bottom left. So these are corresponding angles. Let's see if I can write better now. That's a little bit better. Corresponding. Okay, now here's how you know. If they're going to be one of the alternate interior, alternate exterior, they're on opposite sides of the transversal. If it's going to be corresponding, they're going to be on the same side of the transversal. Okay, so that's kind of a tip. All right, then we jump right into the interesting stuff. Number 5, Arturo is designing a bridge for science class using parallel supports for the top and bottom beam. So that means this and this are parallel. Find the measure of angle 2 and the measure of angle 3 if the measure of angle 1 is 60. So I'm assuming that this here is angle 1 right there, okay? And that is 60 degrees. So it is going to be alternate interior with angle 2. So measure of angle 1 and measure of angle 2 are going to be equal to each other. So the measure of angle 2 is also 60 degrees. But they also want the measure of angle 3. Now the measure of angle 3, we're going to have to do a little math to get to it. The measure of angle 2 added to 3 makes a straight line. So what we do is we take the degrees in a straight line and we subtract 60 from it, all right, because that's what angle 2 is. And then when we get this, we get 120. So the measure of angle 3 is 120. Like being a math Sherlock Holmes, you got to figure this stuff out. All right, number 6. In the figure, line M is parallel to line N. They always have to say that. It's like the legal stuff at the end of a commercial. The measure of angle 3 is 58 degrees. So 3 right here is 58 degrees. Okay. What is the measure of angle 7? They want this one. Okay. Well, this is interesting. There are several ways to solve this problem, but here's what I'm thinking. Angle 3 is corresponding with angle 10. See how it's bottom left-hand corner, bottom left-hand corner. So this one would also be 58 degrees. Well, if this one has the little 90 thingy, so we know 6 is 90 degrees, and we know this is 58, what's this? Well, wouldn't this whole thing be 180? Doesn't this whole thing make a straight line? So how much is 90 plus 58? 90 plus 58 is 148. And if we subtract that from the 180, we'll get this little piece that's left here. Remember borrowing? You used to do it in grade school. 32. So 7 is equal to 32 degrees. So far, so good. Haven't screwed up yet. Number 7. The symbol below is an equal sign with a slash through it. It's used to represent not equal to in math, as in x is not equal to 5. If the measure of angle 1 is 108, classify the relationship between angle 1 and 2. Then find the measure of angle 2. Well, 1 and 2 are on opposite sides of the transversal, so they're alternate, and they're outside the parallel line, so they're alternate exterior. Okay? And we want to find the measure of angle 2. Well, alternate exterior angles have equal measures, so angle 2 is also going to be, measure of angle 2 is also going to be 108. Okay. Number 8, now we're naming things here. Angles 1 and 8. Okay, here's 1, here's 8. They're on opposite sides of the transversal, so they're alternate, and they're outside, so they're alternate exterior. Okay, so this is true. 1 and 8 are alternate exterior angles. 3 and 7 are corresponding. 3 is the top left, 7 is the top left, so they are corresponding. 2 and 8 are corresponding. 2 is the bottom right, and 8 is the top right. They are not corresponding angles, so we don't mark that one. 4 and 6 are alternate interior. Here's 4 and here's 6. They're on opposite sides of the transversal, so they are alternate. They're inside the parallel line, so they're alternate interior. This is correct. 5 and 7 are corresponding. No. 5 and 7 are actually vertical angles. Angles that share a vertex are called vertical angles. They are not corresponding. So the only correct ones were the first one, the second one, and the fourth one. Okay. All right, number 9. Angles A and B. Now we get to the algebra part. Angles A and B are corresponding angles formed by two parallel lines cut by a transversal. Now let's think about this for a minute. Corresponding angles are equal. Okay? So we know A and B have the same measure, all right? So the measure of angle A is equal to the measure of angle B, okay? It says if the measure of angle A is equal to 4x and the measure of angle B is equal to 3x plus 7, what's the value of x, all right? Well, because we know A and B are equal to each other, we can substitute these values for this and this value for this, and then we can solve for x. So what we get is 4x is equal to 3x plus 7. And we've done problems like this before. This is just an equation that has variables on both sides. When we do that, we want to get rid of the smaller variable, which would be 3x. So we subtract 3x from both sides, and that gives us x equals 7. And it just wants us to find the value of x, so x is 7 right there. Well, so messy. Okay. And number 10, more algebra. In the figure, line M is parallel to line N. If the measure of angle 3 is 7x minus 10, and the measure of angle 6 is 5x plus 10, what are the measures of 3 and 6? Well, let's look at 3 and 6. Are they equal to each other? Here's 3, here's 6. They're alternate interior angles, and alternate interior angles are equal. So the measure of angle 3 is equal to the measure of angle 6. And it wants to know what their measures actually are. Okay, so we're going to have to find out what x is equal to. All right, let's do that by setting these two equal to each other. The measure of angle 3, well, I'm doing 6 first. The measure of angle 6 is 5x plus 10, and that has to be equal to the measure of angle 3, which is 7x minus 10. Getting rid of the smaller of the two variables, we would subtract 5x from both sides. And that gives us 10 is equal to 2x minus 10. Now we want to isolate our variable by adding 10 to both sides so we can get rid of this guy. We have 20 equals 2x, and it doesn't take a whole lot to figure out that x is 10. So if the measure of angle 3 was equal to 7x minus 10, and we now know x is 10, so this would be 7 times 10 minus 10. 7 times 10 is 70. 70 minus 10 is 60. So the measure of angle 3 is 60 degrees. What about the measure of angle 6? Well, the measure of angle 6 is equal to 5x plus 10. Okay? And since we now know x is 10, we would say 5 times 10 plus 10, which gives us 50 plus 10, which gives us 60, which tells us that the measure of angle 6 is 60. But you know what? We already knew that because we knew the measures of angle 3 and angle 6 were equal. Here, I'm not crazy about number 11. Number 12 is a pretty straightforward question. If a transversal intersects two parallel lines, the measures of the alternate exterior angles are equal. We know that's a rule. They've already told us that. So yeah, 12 is true. Done. Now these are a little more interesting. Determine the measure of W. Construct an argument that can be used to defend your solution. Well, my argument is that I'm a math teacher and I say so. So there's that. But I bet I can find the measure of angle W. Let's see. Where to start? I do know that this angle and this angle are vertical angles and therefore will have the same measure. They're formed by these two intersecting lines. So that means that 85 plus W has to equal 148. Well, what do I need to add to 85 to get 148? Let's start by subtracting 85 from 148. And that would be 6. So W is 63 degrees. Boom. Find the error. A student was finding the measure of angle 5 in the figure below. She concluded that the measure of angle 5 is 86 because it's a corresponding angle with 2. Okay? Find her mistake and correct it. She says this angle corresponds with this angle. First of all, those are not corresponding angles. Those are vertical angles. Okay? Let's see. 2 would be the same as 5. Wait a minute. It says the measure of angle 5 is 86. Okay, so they're saying that this one here is 86. And so they're saying that one would be 86. No, that would not be 86. This one would be 86 because these would be corresponding angles. So that's not 86. There we go. And 2 would be whatever 180 minus 86 is. That's what you should have done. That's what it is. Okay, well, that's a short video. 12 minutes. You guys got off easy. Maybe we'll try some GimKit when you guys are done doing this. Go on over to McGraw-Hill and do the practice assignment real quick. And let me know when you're done so I'll know if we have enough time to do anything else. Something fun, okay? All right, see you guys in class.